to scale up from the small fermenter into the larger fermenter, okay, these procedures can be used. Okay, you can use on the similar Reynolds number or momentum factors. Can also use the constant power consumption per unit volume of liquid, Pg/V. Okay, or you want to have this constant imperative velocity, okay, NDI, okay, in order to scale from small to larger fermenter. Or you can have this equal mixing and recirculation time, TM. Or also you can have the constant mass transfer coefficient, the KLA. Based on the KLA, you can scale up the fermenter. Okay, for the aeration agitation, okay, we may deal difficulties involving the supplying of oxygen if it is a aerobic bacteria, okay, to the large volume of actively respiring culture, the aerobic bacteria, for the production. Okay, so the objective of any aeration and agitation scale up procedure, okay, what you need to have is you need to obtain the same oxygen transfer rate, okay, on the large scale as on the small scale. Okay, this procedure can be done, okay, by using the following relationship. Okay, the equation shows here, right? The KLA, okay, value equals to 2.0 times 10 power of -3 PA/V power of 0.7 times the superficial gas velocity power of 0.2. Okay, this is the Van Rat equation. Okay, so you can scale up the reactor based on the KLA by using this Van Rat equation. First, you need to identify the mass transfer, okay, mass transfer coefficient of the small scale, okay, and then by using that value of KLA, okay, you substitute in this Van Rat, and then you may able to calculate the dimension, okay, of the impeller required, okay, as well as the by using the volume, okay, by using the volume of the larger reactor, okay, and in this method, okay, the conditions are found, okay, by the experimental value for the smaller scale, okay, in order to design the larger scale of reactor. Agitation is a very important element in fermentation. In order to have this adequate mixing, okay, to mix all this media, cell or oxygen being supplied, and also the nutrients introduced or supplied in the fermentation. Okay, so it is also used in order to reduce non-uniformities in the fluid, okay, by eliminating the gradients of concentrations, the temperatures, and other properties. Okay, by using the agitation, okay, in the bioprocess, you may able to blend all the soluble components in the liquid media, okay, such as sugar, the carbon sources for the microbes, and you may able to disperse the gas in the liquid media, okay, in the form of small bubbles, okay, and by using this agitation, we can maintain the suspension of solid particles such as cells and cell aggregates, where if it is necessary, okay, it may disperse the immiscible liquids to form an emulsion or suspension of fine droplets, and this agitation also can promote a heat transfer to or from liquid.